Alright, so now if we wanted to model some real-world data with functions and actually find out some interesting questions, we would start off with the important question of how long would it take for my money to double? One of the most important questions you could ever ask yourself when you're investing money. Okay, and doubling time, and this is not investing money in the stock market, this is actually putting your money into an account and having it grow. Okay, the doubling time is going to be equal. Okay, now the key thing you need to find is k, and obviously if we're dealing with k, we're definitely dealing with an exponential growth of decay. All right, so please understand when you're given a problem and you have k, you can actually find the doubling time by plugging it into this formula, the natural log of 2 divided by k. All right, so something pretty simple as that. All right, now on to nonlinear regression. Okay, so here we are at metacalculator.com, and I clicked on the statistics calculator, as you can see. Okay, now in regression analysis, obviously I'm going to start by having this in basic statistics, so I'm going to go to regression analysis. Okay, so what you're going to do is click here, and then whichever method you want, you could do exponential, power, logarithmic, natural, logarithmic. It's totally up to you. You're probably going to be sticking to the exponential, the logarithmic, or the natural logarithmic. Okay, now what you're going to do is you're going to put in your data. So something pretty simple. Okay, so let's get some data sets. Alright, there we go. Let's take a look at it. So I'm looking at the example 2, and it is the year since 1900. The population of the world in billions for select years during the 1900s. So in 1900, I'm going to put 0 for x, and then for y, I'm going to put 1.65 billion. Okay, and then for the next one, I'm just going to punch them in and just work with that as is. Okay, and as you can see, I'm just each year, each x is going to be the year since 1900. And then each population is going to be represented right here. Okay. All right, and I'll finish putting this in and we'll come back and go over it. All right, so I finished putting in the data, and as you can see, now if you were like going, what does this 90 and 5.27 mean? That means in 1990, the world's population was 5.27. Okay, now if you think about this, this is actually going to be an exponential function. So this will be a linear, well, not linear regression, it's going to be an exponential regression. So we're going to click here, and then we go down here to the bottom right-hand corner. You can't see it, it's off the screen, but it's an analyze button. And we click on it, and guess what? We're actually given the exponential equation, okay? The actual exponential regression plot. So this is really cool stuff about it, okay? All right, now, the coefficient of correlation and coefficient of determination you don't need to know as much, but if you've taken statistics, you'll know exactly what these means. But also, it gives you prediction plots. Okay, so if you wanted to actually predict what would happen in the future based upon this information, you could actually do it. You could do, let me see, let's start at 110 because that's 2010. So according to that, in 2010 we should have been at 6.4523 billion. Okay, and just working it up. Now we all know that's a little bit of a lie because we hit about 7.2 billion about last year. So this is a little bit off, so it's not taking into account everything. So we would probably need to include those data points. Okay, now another thing that they're going to want to talk to you about is linearizing the data. Now if you notice, here, let me go to analyze. If you notice, the formula is looking like this. Now if I wanted to actually put it into, okay, let's go back. If I wanted to linearize it, if you notice, if I put it into here, this isn't as good. The lower this number gets away from 1, the worse it is. Okay, so what I want to do is I want to go back and actually linearize the data. So what I'm going to do is I go back to the data, and in order to linearize properly, I would actually take the values that need to be linearized. Okay, now for example, if I was working with something like this, something that was exponential, I could do the natural logarithm of each of these y's and actually calculate it that way. Okay, and then what I would do is I put in that data, and then I would click on the linearization. And guess what? I would get a nice neat formula in the form of y equals a plus bx. Technically this is y equals b plus mx because it's in the form of a line and stuff, but we're just going to go ahead and use the actual notation given in the book, a and b, which are used in there. Okay, Alright, so once again, if you want to linearize the data, make sure you do the natural logarithm of the actual numbers here. You do the natural logarithm of exponential numbers, and if you have a logarithmic data, in other words, it's increasing at a much lower rate, in other words, it's kind of increasing like that, okay, you would do the exponential. You would probably either raise it to the x power or put it to the x power or something like that, okay? Alright. That is it for working with linear regression and modeling data of real-world data. The really cool thing is that you guys can use this to do a lot of models and just to work with it. Just make sure you find one of these and just work with it, and just be very careful how you do it. Okay? All right. Thank you. Have a great day. Bye.